Let's take a look at our second example. It says graph f of x equals negative x cubed whenever x is not equal to 0. So we're going to break this down a little bit more, help you read it. Let's practice reading this piecewise function. Again, this part right here to the left of the semicolon is our function. So this time f of x equals negative x cubed. This semicolon means when or whenever, and x is not equal to 0 is our interval. So let's read this together. F of x is equal to x cubes, not cubes, cubed. Hold on. There we go. Whenever x is not equal to 0. So whenever x is not equal to 0, we have negative x cubed. What does that mean? Everywhere except for 0, there will be a graph. The only place that there won't be a graph is at 0. So that's telling you there's going to be a hole there. The logical conclusion is that we ignore what f of x looks like when x is equal to 0. We're going to graph it everywhere else. Let's proceed to graph the function. Okay. Step 1, circle the interval values. Same steps as we did for example 1. So here's my interval value 0. These are the numbers given in the interval. Okay, pretty simple. Step 2 is to plug the interval values into the function. My function is f of x equals negative x cubed, so I'm going to plug that interval value in to negative x cubed. So plug the 0 in for x, and then you get f of 0 equals 0. Step 3 is to write out that point, so the point's going to be 0, 0. Step 4 is going to be to circle the relation. So this time my relation is x is not equal to 0. Now for step 5, I'm going to determine whether or not that should be a point or a hole. Sorry, it is a point, whether it's a hole or a solid point. So because it's not equal to, it's going to be a hole, right? So the point 0, 0 is going to be a hole. Step 6, plot that point. So at 0, 0, we're going to put a hole because it's not equal to. Step 7, we're going to determine additional points. The interval is your guide here. X is not equal to 0, so we need to choose points to the left and right, right? Because negative 1's not 0, 1's not 0, negative 2's not 0, 2's not 0. This means that you want to choose both negative and positive values. 3 additional points is generally a safe bet. 1 or 2 sometimes works. Okay, I can tell you for this one we need 4 at least, and I just mentioned them. So let's go ahead and plug those in. We're plugging in these into f of x equals negative x cubed because that's our function. So f of negative 1 would be negative 1 cubed because it's... Here, let me go ahead and just write the function out for you real quick. Okay, so we're plugging in negative 1 in for x. It's going to end up being negative 1, which gives me positive 1. So my first point is going to be negative 1, 1. Not my first point, my first solid point, which I will put right here. Next up, we're going to plug in negative 2. Again, it's a double negative, so I get 8 back. So my next point is negative 2, 8. Now, how do we know they're solid? Well, because they're not at 0. As long as x is not equal to 0, it's part of the graph. Next up, we have plugging in 1. So we get negative 1 cubed, which is negative 1. So our next point is 1, negative 1. And finally, f of 2 would be negative 2 cubed, which will give me negative 8. So 2, negative 8. And then I'm going to connect the dots for step 9 after step 8, plotting points, in case I didn't mention that. Now it's important to note that we will not go through this hole because, again, the graph says it's going to be negative x cubed as long as x doesn't equal 0. When x equals 0, there's no graph. That's why we call it piecewise function. So which pieces did we take from the whole graph? We took the left part of x equals 0, and we took the right part of x equals 0, and we graphed it. We did not graph it at x equals 0. Alright, that's it for this example of graphing piecewise functions. If you have any questions about it, let me know.